Welcome to The Explainer. Today, we are digging into a brand new open source model that tackles what is, for many of us, the absolute worst part of any data pipeline: getting clean, structured data out of messy documents. It's called Granite Dockling, and it's a powerhouse model in a surprisingly small package.
Look, if you've ever built a document workflow, you know the drill. The old way is this clunky, multi-stage pipeline. You've got your OCR model, then you pipe that to a layout analyzer, then a table extractor. It's like a house of cards where one mistake brings the whole thing down. Granite Dockling just completely changes the game. It's a single vision language model that does everything in one shot, preserving the document structure and making it ready for RAG. The difference is night and day.
All right, here's our game plan. First, we'll quickly touch on why parsing is such a pain. Then, we'll dive into Granite Dockling's approach. We'll look at its secret sauce, a format called doctags, and then we'll pop the hood on the architecture. Finally, we'll talk about why its tiny 258 million parameter size is its biggest superpower.
Okay, so let's start by framing the problem here. Because for anyone who's ever dealt with PDFs, you know it's not just about reading the words, it's about understanding the whole page.
The traditional way of doing this is basically a line of dominoes waiting to fall. You have all these specialized models, one after another. If the first OCR step messes up a single character, it can throw off the layout analysis, which then breaks the table extraction. By the end of it all, you're just dealing with a cascade of errors. Garbage in, garbage out.
And here's the fundamental issue. Trying to squash a visually complex PDF into a simple linear format like Markdown? Well, you're gonna lose stuff. It's like trying to describe a painting over the phone. All that rich context, the relationship between a chart and its caption, how a table is structured, the reading order of columns, it all gets flattened out and lost.
And this is exactly where Granite Dockling completely flips the script. Instead of treating a document as a bunch of separate problems to solve, it sees it as one single challenge.
So what is it? At its core, it's a vision language model, a VLM. You can think of it as having both eyes to see the page layout and a brain to read the words, and it uses both at the exact same time. This lets it understand the entire document holistically, all in one go.
And the result is this beautiful simplicity. One model, one pass through the document, and you get a full, high-fidelity representation. No more falling dominoes, no more cascading errors.
So how does it actually preserve that precious document structure so well? This is where we get to the really clever part. The real innovation here is in the output format itself.
So let's take a look at a classic nightmare scenario. A page from a dense academic paper. You got it all. Multiple columns, complex equations, tables, the kind of document that makes traditional OCR tools just want to give up.
Now, when Granite Dockling looks at this page, it doesn't just see a wall of text. It sees everything. It identifies the headers, it segments the paragraphs, it finds the figures, it even breaks down tables into their individual cells, all while understanding their exact coordinates on the page.
And this is what it spits out. It's not some messy HTML or ambiguous Markdown. No, it's this incredibly clean, purpose-built format called doctags. And here's the genius of it. It completely separates the what from the where. You get the text content, and you get the layout information, like bounding boxes, as distinct metadata. That separation is the whole ball game.
So why is this separation such a big deal? Well, if you're building RAG systems, and let's be honest, who isn't these days? This is pure gold. It means you can perform much smarter searches. You can ask your system to find text within a specific context, like find all the numbers in the summary table, or get me the caption for this figure. You're feeding the LLM much richer, more precise information, which means you get way more accurate answers back.
All right, for all the engineers watching, let's pop the hood for a second and see what's powering this thing.
So this model is basically an enterprise-grade version of an earlier experimental model. It's built on the IDFix 3 architecture, but with a couple of key upgrades. For its eyes, it uses the much more powerful SIGLIP 2 vision encoder, which is fantastic for handling messy, real-world images. For its brain, it's using a 165 million parameter Grane LLM. This combination not only boosts performance, but it also makes the whole thing more stable and reliable.
Okay, so we've talked tech specs, but all of this leads to what is, honestly, the model's most practical and impressive feature: its size.
258 million parameters. Let that sink in. In an era where we casually talk about models with billions or even trillions of parameters, this thing is absolutely tiny.
And here's the kicker. It's not just small. It punches way, way above its weight class. Its performance is competitive with some of those massive, general-purpose VLMs that are orders of magnitude larger. This isn't just about being small, it's about being incredibly efficient.
So what does that tiny footprint get you in the real world? Well, for starters, you can actually run it on your own hardware. No need to pay for a massive GPU cluster. That is huge for building fast, low-latency RAG pipelines. It also means it's incredibly cost-effective to scale up. And the cherry on top? It's released under the Apache 2.0 license. That means it's free to use even for commercial projects.
And this isn't just talk. The numbers really back it up. The performance gains over the previous version are just massive. Just look at the score for table recognition. It jumps from 0.76 to 0.96. That's a ridiculous improvement. Same thing for code recognition. It goes from 91.5% up to almost 99%. This thing just delivers.
So I'll leave you with this final thought. For years, document parsing has been that unreliable, expensive, and just painful first step in so many data workflows. It's always been the blocker. So what new possibilities open up when the hardest part of your pipeline suddenly becomes the easiest? That's the question Granite Dockling is asking. Thanks for watching.